Imagine yourself in ancient Greece. The sun bathes the city of Syracuse in a warm glow. It is a time of brilliant minds, and among them stands Archimedes. He was a mathematician, an inventor, a genius. One day King Hero II presented him with a perplexing problem. The king had commissioned a new crown. It was a masterpiece of craftsmanship, crafted entirely of gold, or was it? A seed of doubt had been planted in the king's mind. He suspected the goldsmith of deception, replacing a portion of the gold with a cheaper metal, silver. Hero turned to Archimedes. Could he determine the crown's true composition? The challenge was daunting. How could one discern the truth without damaging the intricate artistry of the crown itself? Archimedes pondered this riddle. He knew that gold and silver had different weights, but how could he measure the volume of the crown to calculate its density? The answer, as fate would have it, awaited him in the most unexpected of places. Seeking solace and inspiration, Archimedes decided to indulge in a relaxing bath. As he lowered himself into the tub, he noticed the water level rising. A simple observation, yet it sparked a revolution in his understanding. The water displaced by his body held the key to the crown's mystery. Legend has it that Archimedes, in a flash of pure intellectual ecstasy, leapt from the bath, shouting, "Eureka! Eureka! I have found it! I have found it!" His bath-time revelation led to a groundbreaking principle, a principle that would forever alter our understanding of buoyancy and its endless applications. Archimedes' principle, born from a simple bath, states that the buoyant force on an object submerged in a fluid is equal to the weight of the fluid displaced by the object. In simpler terms, an object in a fluid experiences an upward force. This force is equal to the weight of the fluid pushed aside by the object. This principle explained why ships, massive structures of wood and metal, could float effortlessly on water. They displaced a volume of water whose weight equaled their own. Armed with this knowledge, Archimedes devised a plan to unmask the secret of the king's crown. Section 4. Sailing the seas, buoyancy in action. Archimedes' principle extends far beyond bathtubs and royal intrigue. It underpins the very existence of maritime travel. Ships, from ancient canoes to modern cargo vessels, rely on buoyancy. Consider a giant container ship, a marvel of engineering carrying thousands of tons of cargo. Steel by itself would sink like a stone. However, the ship's hull is ingeniously designed to enclose a vast volume of air. This trapped air significantly reduces the ship's overall density, allowing it to displace a massive amount of water. The weight of this displaced water, the buoyant force, keeps the ship afloat. Section 5. Submerged wonders, exploring the depths. The depths of our oceans, once shrouded in mystery, are now accessible thanks to Archimedes' principle. Submarines, underwater vessels capable of diving to astonishing depths, utilize ballast tanks to control their buoyancy. When the submarine needs to submerge, these tanks are filled with water, increasing the sub's density and causing it to sink. To ascend, compressed air forces the water out of the ballast tanks, decreasing density and allowing the buoyant force to propel the submarine back to the surface. Section 6. Beyond the ocean's embrace, from balloons to life jackets. The applications of Archimedes' principle extend beyond the realm of water. Hot air balloons, for instance, rise in the air because the hot air inside the balloon is less dense than the cooler surrounding air. This density difference creates a buoyant force that lifts the balloon carrying passengers and cargo skyward. Even a simple life jacket, a crucial piece of safety equipment, owes its effectiveness to buoyancy. The life jacket, typically filled with low-density foam, increases a person's overall volume without adding significant weight. This increased volume displaces more water, creating a buoyant force strong enough to keep a person afloat. The genius of Archimedes, sparked by a simple bath, continues to resonate in our world today. His principle, elegant in its simplicity, underpins countless technologies and innovations, from the ships that connect our world to the submarines that explore the ocean depths, from the hot air balloons that grace our skies to the life jackets that keep swimmers safe. Archimedes' legacy lives on, a testament to the power of observation and the enduring influence of scientific discovery. Thanks for watching, and see you in the next video.